Today I'm going to introduce the QDrill, which is a framework that can be used to drill into big data for any person. So basically, you don't need to be a data scientist in order to analyze the data you have. So this is our team. So it's a cooperation between Queen's University, myself, and Professor Patrick Morton, and IBM, Dan, Mike, and Craig. So with big data, you have a huge amounts of data that comes in many formats, structured and unstructured, that can be stored on different data storage systems, HDFS or local file system or NoSQL databases or SQL databases. And for many organizations, the key for success is transforming this big data through big data analytics quickly and efficiently into insights, where these insights can be used later on for smarter marketing, smarter customer service, smarter decision making. But now we're stuck with Hadoop, which kind of do a good job in splitting this huge amount of data into smaller chunks and doing the processing in parallel. But is that enough? Let's take this example. Let's say that we have a building and we want to regulate the ventilation and the temperature in it. So we deploy lots of sensors, Internet of Everything or Internet of Things, and these sensors measure the heat, the ventilation, and conditioning. And the objective of our system is to reduce the expenses while adjusting the fan speed. So we're trying to build a model that can adjust the fan speed depending on the readings here. So we have two types of data. We have the sensors sending data in let's say in a log file, which is a semi-structured format, which contains the target temperature and the actual temperature in the current building. And we have an SQL database. Battery is gonna die. So, and we have the buildings, the database, which an SQL database, relational database that stores the information of all of our buildings that we're trying to regulate their temperature. So with the current state-of-the-art systems, we can transform the log files using Apache Flume into Hadoop HDFS. We can use Scoop in order to transform the relational database into HDFS. We can use HCatalog in order to add some sort of a scheme to it so that you can store it in Hive. And then we can use Pig or Hive Mode or Mahout in order to do the analytics on it. And finally, we can use some sort of business intelligence, Excel or Tableau or MicroStrategy or whatever in order to create the reports, dashboards, and all of these stuff. That's lots of software that a person needs to learn in order to do analytics on their data. And for lots of companies, that might make them think not to go with the big data analytics at all. So basically, we have this is the process for doing big data analytics, but then we have lots of users here. We have the data scientists that are familiar with these complex software like R, Weka, Mahout, or MATLAB. But we also have the business analysts, the marketers. We have the frontline workers that only know using Excel and business intelligence tools. So we're trying to fill this gap, making these users, non-technical users, able to do big data analytics without having to do or having to learn these sophisticated piece of software. So we have 4 challenges that we want to address in this work. So we need a system that can handle big data heterogeneity, a system that can access data of different formats stored on different data stores. We need a system that can handle engine heterogeneity. So basically, I don't want the user to get stuck with R. I want the user, if he wants to use Weka, he can use Weka. If he wants to use MATLAB, he can use MATLAB, but without learning MATLAB and Weka or R, just something that provides an interface for all this. I want something that provides consumable analytics, which is a system that allows organizations to use their in-house expertise, whether these expertise are database users or programmers or business users. And provide scalability because we're dealing with big data here, so it needs to run in a distributed fashion. But I don't need to rewrite all of the data mining algorithm. I'm not gonna re-implement the neural network to run in parallel. I want something that would run neural network in parallel without rewriting the neural network code itself. So here comes Apache Drill. So Apache Drill is a system developed by Apache and supported by lots of organizations. The most one supporting it is MapR. So it provides an SQL query layer and execution engine, and a storage adapter. So basically, it allows you to access data of different formats stored in different data systems. So basically, you can write an SQL query just like any relation database, and it can access Hive, HBase, MySQL, or HDFS, MongoDB, and lots of other data stores. And it provides a very simple statement. So basically, remember our example where we needed to join between a log file and an SQL database. So here I can just select all from the file system, and this is the path to my log file, and then I can just join it with my SQL table building on this speed, and that's it. I don't need to worry about like learning how to use Flume or Scoop or any of these stuff. It will just do everything for me. Not only that, but it also provides JDBC, ODBC layer. So basically you can use Java, Python, or any business intelligence tool you wish to use on top of it. So basically it's very easy for business users to use. But Apache Drill only provides big data heterogeneity. So it does support big data heterogeneity and access the data from different data sources of different formats. But it doesn't provide any form of analytics. So it doesn't provide engine heterogeneity. It provides scalability for data access, but not for analytics. And it doesn't provide any consumable analytics. So basically, we started working on these 3 points in order to support analytics, consumable analytics, by extending Apache Drill to provide these features. And we came up with the Queen's Apache Drill. So basically, this is everything run, like these are different nodes. Everything is being run in a massive parallel processing paradigm, so it doesn't use MapReduce. We modified some of the components. So basically, we modified the distributed query planner and the query engine, execution engine, where like you submit a query, the distributed query planner fragment this query into a number of fragments and distribute these fragments on all of these nodes. So basically, we modified that so that if the query contains any calls to a data mining functions, then instead of going like for the regular path, the Apache Drill path, it will send it to our engine adapter, which is a new component we've added to Apache Drill. The engine adapters allow Drill to access any of these engines. So basically, on all of these nodes, you have R installed, you have Weka, you have MATLAB, and all of the libraries you want to use. And the engine adapter provides seamless access to them. So basically, you don't need to write any R code or Weka code or whatever. You just write in your SQL query, and it will do the transformation and data format conversion for you. So to train a model, like let's say you want to train a neural network or a naive Bayes or whatever, you just use this statement. So basically train, you supply the model name as select, and this is the function using Weka. So if you want to use R, you just replace Weka with R. You specify the algorithm, which is like neural network or naive Bayes or whatever, the arguments and the data, and then use, like you mentioned, the data source, which can be a file on your HDFS, a table in HBase, a table in MySQL or whatever. And you can also do joins here, so basically you can have the data from multiple data sources. If you have a model and you want to update it, so like basically you got a new training set, so you can do that as well. So you can use the QDM update Weka, and then you apply the new data on the old model using the applying keyword that we introduced. And if you want to do scoring, so basically you just do the statement here. So QDM, Queen's Data Mining, score Weka, that's again using the Weka model to do the scoring, and you apply the model name that you've just trained in the first statement. So basically, everything is done in the distributed fashion. We didn't write any of the code in Weka or R or whatever, and it's very simple for any user to write down. It's just like 3 lines of SQL statements. So back to our example, like sensors, that's the state of the art. So if you want to implement the same thing using Queen's Drill, so to join the data of the 2 files, the log file and the database, so it's just a simple join statement, SQL statement. If you want to train a model, then I can train model, fan model, where I just call a naive Bayes or Weka naive Bayes and send all of the data, the combined data to it. It will do the training for me. And then if I want to do the scoring in order to predict the fan speed, then I can just use the fan model here. Can just use the fan model on the testing data, and it's going to predict the data, and I can create a table to store all of the data in it. And this creates a very nice workflow. So each of these workflow nodes can run on multiple machines in a distributed fashion. And each node, let's say the create fan, this can be a Weka, like calling Weka functions while using the fan model that can be R, or you can like mix and match between the different libraries you have. So for the evaluation, we evaluated our solution, the Queen's Apache Drill versus Mahout, which is a natively distributed machine learning library running on Hadoop. So the first dimension is the data volume analysis. So we tried using a different number of records with a fixed number of columns. So we have 5 columns per record and 2 classes used. So this is the evaluation. So we can see here with one, that's 1,000 million records. So we can see that Mahout spends most of its time doing the data conversion. So like it needs to transform the data from the CSV format into a vector format in order to do the processing, which takes lots of its time. And then this is the processing part for Mahout. For Apache Drill, sorry, for Queen's Drill, we have two columns here. So like that one, like the black one, this is when you're running a non-aggregatable algorithm. An algorithm like a naive Bayes that cannot run in a distributed fashion. So basically, you load all of the data in parallel, but all of the training is done on a single node. That's why it takes lots of time. But even with this, like this is the worst case scenario. Even with the worst case scenario, it performs better than Mahout because it doesn't need to do any format conversion. It just like loads the data as is and send it to the one node that does all of the training. And for this short one, that's still Queen's Drill as well, but for aggregatable algorithm that can be trained in parallel, and then these sub-models can be combined together, aggregated together. So basically, for this, that's like the best case scenario for QDrill, where everything is done in parallel. In storage-wise, we can see that like this gray area, light gray area, this represents the storage required by QDrill. So it, like for 1,000 million records, it needs around 25 gigs of data, of memory, sorry, hard disk, while for Mahout, it needs around 83 gigs. So basically, because of like the data conversion, so it needs more disk space to store its data. For the scoring, QDrill always performs better than Mahout for obvious reasons. So like it doesn't do any data conversion. So, and everything is done in parallel. So basically the train model is distributed among all of the nodes so that like when the data comes, it can run in a like in real time actually if you want to. So basically it just do like parallel processing for the score. The second dimension is the number of columns. So like the first evaluation was like increasing the number of records. The second evaluation is increasing the number of columns, which fixed the number of records, 100 million records. So we get the same results basically. Like still QDrill performs better than Mahout, but And the third evaluation is scalability. So we started adding more nodes. So these two lines represent QDrill, while these represent Mahout, using the default configuration. So we didn't play with the QDrill configurations or Mahout configurations, just using the default ones. So you can see that QDrill scales better than Mahout, and the scoring scales better than the training in QDrill, because in the scoring phase, everything is done in parallel, while for the training, at some point you need to do the training, like send the data to a single node and do the training. So yeah, so this was the evaluation for Apache Drill, and for QDrill, we still support the big data heterogeneity, like inherited from Apache Drill, and now we support the engine heterogeneity, so you can use any library you're interested in. For scalability and consumable analytics, there is some work that we're doing right now to we provided some sort of analytical scalability and some sort of consumable analytics, but we're not 100% satisfied yet. So for scalability, our problem is that most of the algorithms are non-aggregatable. So basically, most of the cases will have the worst case scenario here. So what we're working on now is using classifier ensembles. So basically, on each of these nodes, we're gonna train a model on a subset of the data and then combine all of these models together. So we started working on that, and we're getting like really nice results. And for consumable analytics, we wish instead of having the statement like this, where you have to specify the algorithm and the arguments, like tuning parameters for the algorithm, we wish to replace this with something like that. So basically, you just mention to the function that I want to do classification operation, and then it will do automatically, like based on your data set feature, it will select the best algorithm of the best library. So basically, let's say that like naive Bayes on Weka performs better than naive Bayes on let's say R for this data set. So, and for that to happen, we're working on that as well. So there's like the case-based reasoning, and there's lots of cases that we can get from the internet, as well as using ontologies, and there is a number of data mining ontologies as well. So like that's another future work that we're working on right now. So that sums up the presentation. So we have 4 challenges: handling big data heterogeneity, handling engine heterogeneity, providing consumable analytics, and providing scalability. We propose that we use Apache Drill, which is an extension to Apache Drill. and that adds analytical capabilities, doing machine learning in parallel without rewriting the code, the algorithms code. And it provides a very simple interface, an SQL interface that anyone who took like a computer science undergrad course should be familiar with. And these are my contact information. And you can download a QueensDrill actually from here. It's like an open source, so like feel free to play with it and leave comments. Thank you.
Do we have any questions?
It's really interesting. Thank you for the presentation. How many libraries have been used in analytical libraries?
So far we're supporting Weka, and we're working on supporting R.
I noticed some Mahout libraries.
So we're evaluating our solution against Mahout. So Mahout is a natively distributed,
Yes.
and we run the Weka, which is a sequential machine learning library, like a library that runs on a single machine,
Yes.
but we're running it on multiple machines, and we're handling the distribution for the user. So like you don't need to worry about.
It's really nice. Great achievement.
One more thing. There's just one more thing. Apache Spark also has their own library, MLib library, and also they're trying to distribute the R also on that. So we would plan to compare your R with Apache Spark R.
Yeah. So like we don't have like much money to do like to rent these big machines. So like on our cluster, when we tried running MLlib, we ran out of memory, and it was like the data set wasn't that big, and we had like 8 gigs of memory and 8 gigs of swap space. So basically, if you have a limited memory machines, you won't be able to run Spark, but you can run Apache Drill, and it will give you like a good performance. The second thing is that yeah, like for like you running R on Spark, you'll need to learn how to use R. Like
Yes.
you're writing R code, right? And then from within R, you can use R Hadoop or R Spark in order to like have the map reduce. Like you have to write the map reduce yourself.
Okay.
But here, like you don't need to worry about that.
Okay. Yeah. Just one more. Actually, I'm working with my advisors. My advisor has another project called Apache Miracle. So he has the same kind of system, but that query itself translates into either Apache Spark or Apache MapReduce or Apache Hama. He's just focusing on the different kinds of distributed framework.
That's like Hive mode, right? Hive mode translate the query into a number of map reduce jobs.
Yeah, but his query can be translated to any
Okay,
distributed
nice.
framework.
That's
Yeah,
pretty neat.
framework query. So it does not. Your is much more interesting because you are actually including those Weka and R analytics things also together. But how easily will be like when we go for the different distributed frameworks, like your query is going for the Apache Spark or Apache Flink, new distributed frameworks coming up, how easily will be this Apache Flink will be able to use it and give it
Like using it
ideas.
with Spark.
Yeah, like let's say Apache Drill now in the background now we are using not Hadoop but Apache Spark or
So like it doesn't use Hadoop and it doesn't use Spark.
yeah.
It's like it's another system. So basically, you have Hadoop, you have Spark, you have Apache Drill.
Okay.
Like they don't run on top of each one another. It's like it's a separate system. It uses massive parallel processing, and it runs its own nodes. So like this doesn't run on Spark nodes.
It doesn't okay.
No.
One more.
Yeah. So I'm hearing that maybe also other recent works go in that direction, but I think that query languages like SQL traditionally deliberately avoid having complex analytics inside them. Meaning, you want to do something like training a model here together with a query to some database doesn't have an effect or some disadvantages like making them too long or increasing the scope of the query language to an extent that we don't really want.
So like we had this argument with the IBM team, so they wanted something that's really simple, and they didn't like the idea of having SQL until we actually finished the prototype and showed it to them. So the idea is that you have a JDBC or DBC connector here, right? So you can have your business intelligence tool that has these buttons and everything, and it will translate that into SQL, right? So basically, like it depends on your user. You can add this on top of like QueensDrill any kind of layers to make it easier for users to access it. But yeah, like I totally agree with you that SQL statement need to be simple. Like if you're gonna write it yourself. Do we have time for one more question? Or?
I think we're good for one more.
Yeah. Then that you have mentioned earlier, when we given some analytical requirement with the data set classification, then we decide which is the most suitable
Algorithm.
algorithm it should be done. What is the logic behind finding the
So,
most
okay.
suitable?
So from a data set, you can extract some features like the number of records, the type of the data itself, whether it's numeric or nominal or whatever, the number of classes, the type of the classes, and all of these stuff, right?
Mhm.
And then you can use this either to build a model, like a machine learning model, so that it would recommend which algorithm to use with it. Like you have to train this model with
Yes.
lots of data sets, like features of it. Or you can use case-based reasoning. So basically you have all of these cases with the best model that worked with them. And then when you have a new data set coming, then you can compare its features with like the features of the data sets that you have seen before. And based on that, you decide which algorithm to use.
It's also trained behind.
Yeah.
Uh,
Thank you.
So this concludes. Yeah.